Hello everyone. Today is the final lessons online for the preparation of the 2022 PSLE science paper. Okay, basically today we'll see several questions from this school, PHPPS, Pei Hwa Presbyterian Primary School. This school is also where Mr. Yu taught there for 6 years. Out of these 6 years, I was being sent to the school by the school to mark the PSLE science paper 3 times, 3 consecutive years. I was a PSLE science marker. So let's go through this question together. Okay, you notice this question is testing on material science, which is actually a P3 topic. So they say state 2 properties. Okay, state 2 properties of this thing. So answer is very easy. Is strength and flexibility. Okay, strength and flexibility. So you can write down your answer first, where I prepare the hold on first. Somebody is trying to come in. Okay. Strength and flexibility and the answer for this. Okay, next question. Okay, so strength and flexibility for the first question. Okay, next one, part B. Strength and flexibility is the answer for the first question. Next. Okay, this is also material science, quite easy. Even P3 student can answer. So based on the result above, explain why material X is not suitable. Okay, you can see it absorbs a lot of water, right? Because in order to make an outdoor tentage, the material need to be waterproof. So you say that as X absorbs the most amount of water, hence material X or X is not waterproof. That's why it's not suitable. Okay. So as X absorbs the most amount of water, hence X is not waterproof. An outdoor tent need to be waterproof. Okay, you can say an outdoor tent needs to be waterproof. Okay, so we have done these 2 questions. Again, I screen share and send to you now. Okay, next question. Okay, take a look at this question before I discuss with you. Okay, this one is about the surface area involved in the biscuit. Okay, so Jeremiah conducted an experiment to find out if the amount of liquid. So important because this is the last lesson, so I need to remind you to annotate this thing when you read the question paper. Okay, so what is the aim of experiment? Is to find out if the amount of liquid Y affect the time taken for the piece of biscuit to break down completely. So during the exam, I want you to do this thing. So I give you a final reminder here. You put an aim here of the experiment. So this is the result. Jeremiah recorded the result. Okay, even notice there is a deliberate effort to jumble up the numbers. Okay, technically if you put 50 followed by 100 and 500, the answer is very simple. So there's a deliberate mixing of the numbers. Okay, so you rearrange the numbers and you'll see the pattern. It's very simple. So when the amount of liquid Y increases, the amount of time taken for the biscuit to be digested, what happened? Decreases. Okay, so this is an inverse relationship. Just now I mentioned about direct relationship. So this is an inverse relationship. Inverse means as one increase, the other decrease. Okay, so when the amount of liquid Y increases, the amount of time taken for the biscuit to be digested decreases. Okay, decreases. So there's the answer for this part. Inverse relationship. So one increase, the other decrease. Okay, what's the reason? Because there's more digestive juice. Okay, because you have more of this liquid Y. So I will save this. So this question is related to here. Okay, you notice that this is part of the stomach being damaged. So they say the diagram below shows how the stomach can be damaged by cancer of the stomach. In fact, this illness has taken the lives of many people in modernized country like Singapore. So we need to watch our food that we eat. Try to eat your meals with concentration. That means don't be distracted when you eat, because this may affect how your food being digested. So they say explain how digestion of food will be affected after part of the stomach is being damaged. Okay, because part of the stomach being damaged, it means that less liquid Y will be released, correct? So you say that less liquid Y is released by the stomach, so less digestion will take place in the stomach. Therefore, food takes longer to be digested. Okay, so this part, simple. I give you a few seconds more to jot down the answer as I send over the screenshots over from here. Okay, sending over the answers. Okay, next question. Okay, this one is a very tricky question. So I want to highlight here. This is tricky. I hope this question comes out in the exam. Okay, examine this question first. Why is it tricky? Okay, the question says, Jolene heated some soup to a temperature of 80 degrees Celsius. So I want to underline this one. And poured into 3 similar size bowls ABC made of different materials. So you got to understand these 3 bowls are made of different materials. After 12 minutes, she measured the temperature of each tower. So she measured this tower here, not the bowl. She measured the tower. Okay, you must understand heat always travels from a higher temperature to lower temperature. So all the bowl contain 80 degrees Celsius soup. So the heat will flow from the soup to the bowl, right, to the tower. Okay, to this tower. This is how the heat flow. Okay, from the, you can annotate this in all the 3 bowls, the arrows pointing. Okay, so you notice this is the temperature of the tower. And can you notice this is the lowest? Okay, that's means in setup A, the temperature of the tower has the lowest temperature. Okay, part A is very easy. Part A is actually testing your concept of heat flow. So they say explain why the tower become warmer after 12 minutes. Okay, this one is quite simple. You just need to mention about the heat from here. Okay. You can say that heat flows from the soup to the bowl to the tower. Okay. So this is the answer. I will paste over here for you to. Okay, this is how you explain. As a bowl came into contact with the soup, it gained heat from the soup. And the tower that came into contact with the tower, it gained heat from the bowl. Alternatively, you can say that the bowl gained heat from the hot soup and the tower gained heat from the bowl. Okay, as long as there's a pattern there that shows that this is being conducted from the soup to the bowl to the tower. Okay, this is a tricky one you put here. This is the tricky part that many students get it wrong, this part. Okay, based on the results above, which bowl contain the hottest soup? Okay, this part contain the hottest soup. Okay, I tell you, most of the time the student will look at here 60 degrees. They'll put B. Okay, most of the student, because they see 60, so they'll write B. And then they try to think how to give the answer. Okay, why do the student put this one? Because they say the tower is 60, so they will think that the soup, right, has the highest temperature. So they use since the tower has the greatest temperature, the soup will also have the highest temperature. But notice 30 minutes has lapsed. Okay, 30 minutes has lapsed, that means has gone. And they ask you which bowl contain the hottest soup. So you must understand heat flow. Because at first it's 80 degrees Celsius. Okay, and then this is a time taken. They measure the temperature of the tower for 12 minutes. Okay, so as the time progresses from 13, 14, all the way to 30 minutes, right, we will expect all the temperature to drop, right? So all these three temperatures, they will drop to even a lower temperature after 30 minutes. Okay, but from here, what can you know? You can know that actually the material for bowl A, right, is the porous conductor of heat. Okay, porous conductor of heat, because the temperature of the tower is the lowest. So it indicates that the heat from the hot soup is finding more difficult to be conducted to the tower because of the material. The material is a porous conductor of heat. Okay, so actually this answer is not B, but it's A. Okay, so which bowl is actually bowl A? So how do you explain? You must explain in terms of the porous conductor of heat. So this is how you should explain. So take note of this explanation. So you say that bowl A, as the temperature of the tower in setup A is the lowest, bowl A is a porous conductor of heat. Or you can say the material of bowl A is a porous conductor of heat compared to B and C. So comparison need to be made. Hence, the soup will not lose heat to the bowl as easily as the other bowl and remain the hottest. Or you can say, hence, the soup in container in bowl A, right, lose heat slowest. Okay, lose heat slowest means it will retain the highest temperature. So this is a tricky one. So you do take note of these two questions. Okay, these two questions, I will save this and send to you now for you to download this part into your computer or devices, plus the previous question. Okay, let's continue. Next question. So do take note, this is a very good question. Okay, more than 60% of the students put bowl B because they see here is 60. So do not be tricked if these questions appears in an exam or similar questions appear. Okay, I'll send the answers to your mom, Isabella, through after the class or maybe during the break time. Okay. Okay, next. This question is also a trick question. This one is also a trick question. I tell you what happened there. A lot of funny answer came out. This part is related to the bowl here, this part. So now it says, Jolene later placed all the 3 bowls in an air-conditioned room for 12 hours. Because many students, they did not look at this part. 12 hours is half a day. So if you leave the hot soup there, even for maybe not 12 hours, for 3 hours, right, you return to the same temperature. Okay, same temperature. Yes, correct. Yeah, Ming, so this is the last lesson for this class. There's one more lesson for you on the 3rd of October. Yeah, that's on the 3rd October. Today is the last lesson for the weekly online class student. Okay, so this answer is very simple. It's 24. Okay, 24 degrees Celsius. Okay, you know some students, they look at here, I don't know how they calculate. They give me answer like 51, 41 degrees. They try to see the pattern. They try to work out some like mathematics. So it's not. So it's this one. It's 12 hours 24. Okay, give a reason how using same thickness of the bowl helps to make the experiment a fair test. Okay, this one has different ways of answering. But this question is actually testing your understanding of actually the thickness of the bowl affects the rate of heat flow. It means the thicker the bowl, right, the slower the heat can flow out. So actually this question, you just put out this part. Very simple. They say give a reason. Okay, give a reason. So you just put this one very concise answer. The thickness of the bowl, would affect the rate of heat flow of the hot soup to the bowl. Okay, the rate of heat flow. So this is the keyword here, this part. So this is the keyword, the rate of heat flow. Okay, the rate of heat flow. Okay, the other way of answering is for the experiment to be fair, right? There can only be one change variable, which is the material of the bowl. You can also answer it in that manner. Okay. Okay, next question. This is question 34. Okay, same thing. Annotate purpose of the experiment. Find out the colors which most bees prefer. So this is the aim. So annotate this one. So in your exam, you can do this. Underline, I'll put the aim on top. Okay, so you need to understand, they put the sugar liquid at this part, okay, in the center of each flower. And these are model flowers. That means they are not real flower, like paper flowers. So Ziwen counted the number of bees that visited the model flower over 4 hours. And you notice it's from the first hour to the 4 hours here. And which one has the greatest number? You can highlight this one, because this one, if you see all the throughout the 4 hours, it recorded the highest number of visits by the bees. So what's the purpose of placing the sugar liquid on the model flower? Is to attract the bees that would land on the sugar water. So this answer is quite straightforward. Is attract the bees. Attract bees that would land and feed on the sugar or liquid. Okay, next. This one is from the observation here, because it asks you, based on the result, which color is the most advantageous for the flower? Okay, you notice this is a 2-mark question. Yeah, the result can be applied. It's a simulated one. Okay, this one. Okay, so this is a simulate the real flower. So they say, so which color is the most advantageous? Is yellow, right? Which is highlighted. So you understand yellow, as the yellow model attracted the most number of bees. Hence, there is a higher chance the flowers will be pollinated. Okay, so this is the answer here, this part. I put it here for you. Most advantageous for the flowers means good for the flower. Okay, so you put yellow, as the yellow model attracted the most number of bees, hence there is a higher chance the flowers would be pollinated and fertilization can occur. Because they are asking you explain your choice. That's when they say in real life, right, why is this good for the flower? Okay, if you look at the question here, this part I scroll back. Okay, they want to find out the color of flowers which most bees prefer. That's mean in real life, they want to find out whether in real life, do the bees like black, yellow, or green? So now in an experiment, they use model flowers to do it. Okay, they use not the real flower, but because they just want to test the color. Okay, they want to test the color, so they use model flower. But in this question, they ask you which color is most advantageous for flower. Means in real life, which color do you think is best for the flower? And then they ask you explain your choice. So they like yellow, like so what? Okay, so this is like a so what? Why the bees like yellow? Because this will cause the flowers to be pollinated, because the bees visit the flower, right? Okay, increase the chances of the flowers being pollinated and fertilized. Okay, so I hope you can understand this part. So what, this part? Yeah, so somebody asked me, is it possible? Yeah, you can do simulated things. You can use a yellow flower, but you must have because they use a sugar liquid, right? Because you know that bees like honey, right? Yeah, bees like honey. So you must something that the bees like. Okay, next, very easy. Find out how the size of flower, so underline this part, size of flower affect. So you must change the size. Okay, don't describe two changes. So she should keep the flower color of flower the same while using different sizes of flowers in experiment. So this part. Okay. So she should keep the flowers. Okay. She should keep the flowers, the color of flower constant, means the same, and use different sizes of flowers in the experiment. Okay, so this part. Clear? Good. Okay, next question. Okay, this question, for those students who have a copy of my book, you will notice this question, the diagram is very familiar, right? Those of you who has my book. So I like to draw your attention to this part. If you have a copy of my book, because I use this diagram to teach a concept in my publication. So I want to show you what happened here. And as an author, I find very happy because the school used one of my question to test the student. Okay, you look at this question here being showcased here, right? So they say Yu Ming used the setup below to ensure that the plants in his garden do not overheat during hot weather. He hung a copper wire across two wooden poles. So let me annotate. So this is the wooden pole, here and here. And this is the copper wire. Copper wire. Okay, this part. They already highlighted the copper wire here. Okay, and set up the water sprinkler system below. So when you look at this diagram, you must visualize how this thing works. So this is called visualization. Okay, number one, when the weather is hot, you can draw like the heat from the sun heating up this copper wire. So copper wire, right, because it's thin, so it will gain heat and expand easily, so it become longer. As it become longer, you know this part, there's a copper bar, there's a weight there. So the weight of the copper bar will cause the wire to drop downwards, and this part will be connected by the copper bar. So when that is connected, you look at here, this is a battery. So electricity will flow through here, turning on the water sprinkler. Okay, this water sprinkler will keep on spraying water until the temperature become lower. The copper wire will lose heat and contract. So when contract, this part will no longer be in contact. Okay, they become an open circuit. Electricity stop flowing, water sprinkler stop spraying. So this is how this thing works. So now they ask you explain how the water sprinkler gets switched on during long periods of hot weather. So I like to draw your attention to my book. You can see here in my publication here, I have this question on page 71 of my book. You see this part? Okay, the wooden pole is here. Okay, for me, I use steel wire. In the exam, they use copper wire. And I made this triangular thing. I find triangular more interesting. Yeah, it fits into the slot easily. Okay, instead of a flat copper bar, I use a triangular aluminum weight. Okay, because aluminum is light and is a good conductor of electricity. So actually this question, I test my student. So the same thing. Explain how the water sprinkler gets switched on during long periods of high temperature during the day. Okay, I use the word high temperature during the day. And then state the property of the triangular weight, which is necessary. Okay, so this property is it must be a conductor of electricity. So I have this concept to help students to understand first before you fill in the blanks on top. Then you see this part, right? I designed this thing here because when I published this book, it was during the COVID-19 pandemic. So I have designed this thing called the anti-COVID-19 virus diffuser. So that means when this is being turned on, the object X, right, a closed circuit, there's a battery inside with built-in batteries. So they will spray this, like air freshener, like they call the word air sanitizer, right? They will diffuse the anti-COVID, spray the thing. So in my question here, I say, okay, object X is magnetic. Okay, object X is this thing, is magnetic. That means it's made of a magnetic material and it's free to rotate at this hinge. I explained this hinge. Explain clearly how the iron rod, which is here, the iron rod here, is able to turn. Okay, this part, this iron rod, okay, explain clearly how this iron rod is used to ensure that this diffuser, right, cannot be turned on when the water sprinkler is in operation. I make it more interesting, because you see when the water sprinkler is in operation, this thing will come down, right? Correct? Yeah, so this thing will come down and then the iron rod becomes a electromagnet. So when that becomes an electromagnet, what will happen? This object X will swing towards here because it's magnetic, it will be attracted. So in that case, this side, right, will have a small hole, a small gap here. Okay, so this gap will form an open circuit. So even you want to close this switch here, right, you cannot turn on the antivirus diffuser. Okay, so now I come back to the question in this school, right? Now they ask you this question. Okay, this question here. Coming back here. So, okay, explain how the water sprinkler gets switched on. So you can try to answer. So during hot weather, the same thing. The hook copper wire gain heat and expand. So the copper bar, right, will touch the metal contact. This will form the closed circuit. Okay, so you write down this one. During hot weather, okay, maybe instead of write the hook, right, I just say the copper wire, easier. The copper wire would gain heat and expand. The copper wire would gain heat and expand. Okay. Gain heat and expand, lowering the copper bar, correct? Lowering the copper bar, not box, copper bar, to touch the metal contacts. This forms a closed circuit and electricity will flow through the circuit. to activate the water sprinkler. So this is how this thing works. Okay, if you remove stigma, okay. Okay, so this is the answer for this. Okay, next part they say Yu Ming wanted to add a pesticide sprinkler. Just like mine is anti-COVID-19, this is pesticide sprinkler. However, it is automatically switched off when the water sprinkler is switched on, which I explained to you in my book, right? So here you're supposed to use the electromagnet and this iron hinge to complete the circuit diagram here. Okay, so now I teach you how you draw. So from here, right, let me use the purple ink to draw. Okay, so you notice, right, this is the part is not connected. So from here, you extend this part, you got to draw the electromagnet. Okay, the electromagnet. Okay, just briefly draw this part, the electromagnet. Okay. Okay, then here you're going to connect to this part, the electromagnet, to one end of electromagnet. And this part you're supposed to put a hinge, you know the hinge thing? Maybe I use another color to draw the hinge. The iron hinge that can swing one. Okay, maybe I shorten this. Sorry, we draw this. I think I draw the hinge first, easier. Otherwise, it will obstruct. Okay, the hinge, maybe it's from here. Okay, you try to draw the hinge here. Okay, this part connected to the screw, and then connect here. Okay, because for me it's hard to draw, but for you, you use a pencil draw. This part is connected, and then the electromagnet, right? You try to put as close to the hinge as possible. The electromagnet. Electromagnet, you can start as close to here as possible. Okay, this part, the electromagnet. So just shade the electromagnet, the wires going round. Okay, and one end of it connects to this wire here, and then this one connect to here. So you check. Okay, remember here they say like to install a bulb so that it will light up even the water sprinkler is not switched on. So you must imagine when this thing come down, right, they form a closed circuit. So now I want to put a bulb inside, even though this water sprinkler is not spraying. So in other words, right, you need to form a bulb that will light up continuously. So this is a battery source, right? So you just draw the bulb here. Okay, the symbol for that bulb, the crisscross, and then join here and join here. So you see this satisfies the condition. So the bulb is not turned on, right, but it's lighted. Okay, so this will be the answer for this question. Okay, so you draw the bulb here, connect to the electromagnet. The electromagnet connect to this part. Okay, so this is how it works for this question. Okay, let's continue the next one. This is one I extracted from my book, from one academy's publication. You can see here in my book, this anti-COVID. So I put here to guide you to complete your diagram. Okay, so this is a guide. This is a guide for you to complete this diagram here. Okay, so you can use this as a guide. I will screenshot this, and then now we take a break and then come back in about 7 minutes time. Okay, see you later.